Hello, my name is Shiori Fujimori. Today, I'm here to talk to you about animal behavior classification using DeepLabCut. My talk is divided into 6 parts. I will start with talking about introduction, then related works, proposed method, experiment, conclusion, finally references. I like to start by talking about introduction. Recently, pet watching cameras have become popular. This makes it possible to check on a pet from the place we visit using a smartphone or other device. These cameras have various functions, such as recording the pet's condition and communicating with the pet from outside. However, if we cannot keep up with the camera from outside, we need to check the recorded video to see what the pet is doing. If we can know the behavior of pets while going out without checking the video, the surveillance task will be easier. Moreover, knowing the balance between energy consumption by exercise and eating by a meal will help to manage the health of pets. So the purpose of this study is to classify the cat behavior from videos and detect cat behavior to know the amount of exercise and meal intake. In the next few slides, we will be showing you some related works. DeepLabCut is a tool that uses deep learning to predict and track body parts of laboratory animals. DeepLabCut utilizes ResNet and deconvolution layer. The deconvolution layer are specified for each body part and output different images of the joint positions of the animal to be tracked. Each of the output images has a layer that outputs a score map. This score map shows the probability that each body position is in a particular pixel. Moreover, ResNet were pre-trained on ImageNet. ImageNet is a massive dataset for object recognition. This transfer learning enables DeepLabCut to estimate and track feature points by learning a small number of additional frames of label data for the body position of the target animal to be tracked. Outlier detection is a method for detecting and identifying data points that would not normally occur. We introduced 2 methods for outlier detection. The first is one-class SVM. One-class SVM is an unsupervised one-class classification method based on SVM. One-class SVM has only one normal class. Therefore, the discrimination boundary is set, and whether it is normal or not by setting the boundary. The second is isolation forest. This is an unsupervised learning algorithm. This method detects outliers based on the assumption that outliers are likely to be less than normal. This method isolates observations by randomly selecting a feature and then randomly selecting a split value between the maximum and minimum values of the selected feature. Random partitioning produces noticeably shorter paths for outliers. Therefore, when a forest of random trees collectively produces shorter path lengths for particular samples, they are highly likely to be outliers. We present 2 methods for moving object detection. The background subtraction method is to detect a moving object by preparing a background model in advance and comparing the background with the input image. Although it is a simple algorithm, it is very sensitive to changes in the external environment, such as sunlight conditions. Another method is the frame subtraction method. Moving objects are detected by calculating the difference between two consecutive frames. It has a disadvantage that if an object is stationary for a while, it will be lost. The next slide shows our proposed method. In this research, we propose a method to classify the behavior of indoor cats captured by a fixed point camera using DeepLabCut. We classify the 5 behaviors: sitting, lying down, eating, walking, and jumping. The figure shows an overview of our proposed method. The proposed method is divided into 3 steps. First, estimate the posture of a cat in an input video using DeepLabCut. Second, calculate the features of the posture in each frame. Finally, classify behaviors using a class classifier. The 5 behaviors can be divided into static and dynamic class, based on whether there is a horizontal coordinate change. To classify static classes, the joint angle is used as a feature and classification is performed by SVM. On the other hand, outlier detection is used to classify the dynamic classes. Jumping will cause a sudden change in the vertical coordinates. Therefore, the change rate of vertical coordinates between the previous and current frame is calculated by DeepLabCut and used as a class separation feature. First, we performed an experiment of static classes. For the dataset, 1,177 frames are used. We used the joint angles of the front legs and hind legs. Using these features, we classify the classes by SVM. The left figure shows the distribution of joint angles for each action. The joint angles of both legs, front leg only and hind leg only, are used as feature points. Right table shows the accuracy of the classification of lying down and sitting down, and classification of lying down, sitting, and eating. The two-class classification shows a high degree of classification accuracy. However, when eating is added, the accuracy is reduced. In particular, when the angle of hind leg only is used as a feature, the accuracy is reduced 51%. As shown in left figure, that there is an overlap in the distribution of eating and lying down. This led to a decrease in the accuracy. Next, we performed an experiment of dynamic classes. 35 frames are used. Using this dataset, feature points coordinates are obtained using 3 methods: DeepLabCut, background subtraction method, and the frame subtraction method. In the proposed method, DeepLabCut is used to obtain the coordinates the front leg. On the other hand, the conventional method uses the background subtraction method and the frame subtraction method to obtain the center of gravity coordinates of the difference image. Next, the change rate of the vertical coordinates between frames is calculated from the coordinates obtained by each method. An outlier detection is performed using one-class SVM. This table shows the experimental results. Comparing the F measures, it is confirmed that the accuracy of the proposed method is higher than that of the conventional method. Shadows of cats are sometimes reflected in the difference images obtained by the background subtraction method. The frame subtraction method cannot accurately obtain a differential image when the cat's motion is small. For these reasons, the classification accuracy of the proposed method was higher. Here is a summary of this presentation. In this paper, we proposed a method to classify the behavior of cats using DeepLabCut. DeepLabCut can keep tracking of feature points without being affected by shadows or brightness. In this respect, it is confirmed that the moving object can be detected with higher accuracy than the conventional methods. However, for actual home use, adverse conditions must be taken into account, such as parts of body being obscured by furniture. Therefore, it is necessary to add feature points such as a head as well as legs to make classification possible even under adverse conditions. That brings me to the end of my presentation. Thank you for your attention.